portion of the video, we'll cover problems 1, 2, and 3 on page 4 times 7. Well, bam! In fact, we're going to do all of the problems on page 7 times 4, commutative property.
Let's take a look at some practice problems. So economics teacher plotted the value of a stock on 11 different days during a 5-year period and used line segments to connect them. In the graph below, the horizontal axis is measured in days, and the vertical axis is measured in dollars. Now notice that it goes from 0 to 550, but we do not have a line for the last 50 days. So it's just counting the 5-year period. Okay, now let's look at what's the question. Based on the graph, describe the range of the value of the stock for this 5-year period. So we need to find the range of the value of the stock. Now by value of the stock, let's make sure we understand what they mean. What they mean by value of the stock is how much the stock is worth. And by range, they want us to find the dollar amount when it's least and it's the most. So we want to find when the stock is worth the least amount of money and when the stock is worth the most amount. And that would be our range for this 5-year period. Okay, so let's take a look at the graph and let's try to see if we can figure out when the stock is worth the least amount of money during this 5-year period. So let's see when it's on the lowest dollar amount. So this wouldn't be it, but here it's at $10. So 10 would be the lowest. Now we want to figure out when the stock is worth the most. So is it worth the most here? No. How about here? Yes. Just notice that it's worth the most here and here. And that is equal to 60. So the stock's range is from $10 to $60. It is its least. So its value is its least at $10, and it's its most at $60. So the range of the stock for this 5-year period is from 10 to 60. I hope that was helpful.
Problem number 2. Buffering.
Hey there, let's get started with a practice problem. So consider the ordered pairs below, which describes the relation. So the first question they want us to figure out is what is the smallest element in the range of this data? So before we can answer that, let's remember what a range is. A range is made up by all the y coordinates in the data, just like all the x coordinates make up the domain, correct? So the y coordinates in this data are always the second element of each ordered pair. Ordered pairs are always written such that, I'll put it right here, so it's always the x and the y. So we can go through and underline all of the elements in the range, all of the y coordinates, and then answer the question by the smallest of those elements. Sounds good? Okay. So the first is 6. Then we have -3. We have -7, and then -6, and then 3, and then lastly 0. So to answer the question, what is the smallest element in the range of this data, we have to find out the underlying element, which is the smallest. See it? So it's not -6 because -7 is smaller. So the smallest element in the range of this data is -7. Not too hard, right? So now they want there another negative 10? No, there's not two y's for one negative 10. And the easiest way actually to determine this is just see if there's any duplicate x's in here. So do we see any other negative 10? No. Any other 4s? No. 0? No. Negative 1? Nope. 3? Nope, not a single 3. Negative 6? No. So there's only one y for every x. So that's how we know it is a function. So it is a function. So the easiest way to determine is the relation of functions is to 1, draw the table, 2. Then look at, is there one pair for every x? Is there one corresponding y coordinate for every x? Then you can determine the function. And the shortcut to determine that is just to see if there's any duplicate x's. And there's not, so it's a function. So just to refresh our memory, a range is represented by all the y coordinates in the ordered pair, and a domain is represented by all of the x coordinates. The y coordinate is always the second element of the ordered pair. To determine if a relation is a function, we can make a table and then make sure there's only one corresponding x for every y. I hope that was helpful.
I think you deserve a brain break for a moment. I think the stormtrooper just got the text from Mr. Phillips that he passed the state exam, or the EOC, and he's doing his happy dance for passing the state exam. Getting jiggy with it. It's also possible that that stormtrooper just found out that the Giants won on Monday night. Or maybe the stormtrooper was happy because FSU won. Not sure. Could be Miss Cole dressed up. You never know. Stranger things have happened. One more. Problem number 3. Last one for this video.
Now let's take a look on how to determine the range and the domain of functions. So the graph of the function fx is shown below. First, they want us to determine what is the domain of the function. Then they would like us to determine what is the range of the function. So first thing, let's refresh our memory. Domain lies along the x-axis, and range lies along the y-axis. So y is the vertical, and domain is the horizontal. Okay, fair enough. And then now let's talk about something else. You see that they have a closed circle and an open circle? Do you remember the